So as we look at section 2, we're going to be talking about what happens if you have infinite limits or limits at infinity. Now, if you remember, is infinity actually a number or is it a concept? It's a concept. It's the idea that it goes unbounded. It goes on forever. So if you look at these first four that are listed here, we're looking for the limit as x either approaches negative infinity or positive infinity. Okay? And there are some special cases that will help us out. Basically, here's what we're going to look for if we're finding the limit as x goes unbounded, either direction. If our variable is in the denominator, like it is here, okay? And that means that the denominator is growing faster than the numerator. In this case, we have some constant in the numerator. The numerator is always going to be a number like 5. But the denominator is going to be growing at a value that is going unbounded in a negative direction. Okay, so x raised, or as x is growing, I'm sorry, not growing, as x is moving toward negative infinity, but there is an exponent on it, okay? Think about that for a minute. A negative number raised to some power as it gets closer and closer to negative infinity, it just gets bigger, doesn't it? Okay, and what would some number, in fact, I know of one calculus instructor who always tries to explain this concept in this way. She calls it the Chinese problem. If you were talking about the population of China, and actually you probably use India now because I think they may have surpassed China as a bigger, more populous country, but there's a whole lot of people in China, right? Okay. So think about it this way. Division means I've got something that I'm dividing out among whatever the denominator is. If I had $5 and I had to divide it by the population of China, because as that thing is growing, it's something that's got that exponent on it, and whether it's positive infinity or negative infinity, as it gets bigger and bigger and bigger and bigger, what's going to happen when I take my $5 and I try to share it with the population of China? How much is everybody going to get? That limit is going to approach what? 0 every time. Okay, if I have just a finite amount of resources and I try to divide it among an infinite number of people, it's going to approach 0. And it really doesn't matter whether I'm going toward negative infinity or positive infinity. It's going to result that way every time. Now, look at 3 and 4. The difference here is we don't have a fraction with our x in the denominator. We have some constant times x raised to a power. Now, if I am moving toward negative infinity, okay, and it's got the exponent on it, depending on the whether it's an even exponent or not exponent, it's either going to be moving toward a positive infinity or a negative infinity, right? Because if I'm moving toward negative infinity and it's raised to the third power, negative infinity times a negative times a negative times a negative is still negative, right? But it's getting bigger negative, okay? Yeah, it's actually moving to the left on the number line, so it's a really, really small number, but it's still negative. Now, if it had been raised to a positive exponent, a negative infinity times a negative infinity would be negative times negative is positive. So it could be moving either toward positive infinity or negative infinity, but it's going to continue to be unbounded, right? Okay, that's because there's no fraction there. So and you'll just have to pay attention to what's involved to see, am I going to end up with positives or negatives when I clean up the signs? But the number part I know is going to be approaching infinity. Now, when we have fractions, rational functions. And I know this looks like a big mess here in this next thing. Basically, here's what it's saying. It doesn't matter how many terms there are, but what I'm going to look at will be these leading terms right here, top and bottom. Because if this is written in descending order, then my largest exponent for my variable will be the first term on top, and my largest exponent on the bottom will also be in the first term. So what I'm going to want to do is I will pay attention if I'm trying to find the limit as x either approaches positive infinity or negative infinity. And I'm going to have to look at it from these three cases, okay? I want to pay attention to just the exponents on the variable. Really, the other stuff that's involved there isn't going to impact me very much. I mean, think about it. If this is x raised to a power, and these are all smaller exponents, yes, I'm adding more stuff on, but as this one is growing faster, these become less important. They just don't change things that much. So I'm only interested really in the biggest exponent on top and the biggest exponent on bottom. Now, here's what I pay attention to. If the exponent on top is smaller than the exponent on bottom, that's really the Chinese problem, right? Because yes, they're both growing now, but if the exponent on bottom is bigger, isn't the bottom growing faster than the top? And eventually I'm going to run into the same problem, that I've got this finite amount on top that I'm having to share with more and more and more and more people, to the point that eventually everybody gets almost nothing, okay? So as long as the exponent on top is smaller than the exponent on bottom, if I'm finding the limit as x approaches either positive infinity or negative infinity, it's got to end up being 0. Okay? Now, if the exponents are exactly the same, think about it for a minute. The one on top is growing at the same rate as the one on bottom. What happens then is all I have to do is take the ratio of these coefficients. So if that was a 5x to the 7th on top plus all this other stuff, and a 2x to the 7th on bottom plus all this other stuff, nothing really matters except the 5 on top, 2 on bottom, and that's going to be what the limit would approach. Okay? And we'll look at specific examples of this. That's when the exponents are the same. It's going to be the ratio of the coefficients. Third case is if the top's growing faster than the bottom. And if the top is growing faster than the bottom, what do you think is going to happen as I take the limit as x either approaches positive infinity or negative infinity? It's going to go unbounded. And I'll, again, have to pay attention to the signs to see whether it's going to be approaching a positive infinity or a negative infinity. And I will look at the power on the exponent and the coefficients to figure that out. Okay? So let's go through a few examples and see if this makes sense. All right, so it says find each limit, and we will use either positive infinity or negative infinity when appropriate. So remember, we may discover that the limit doesn't really exist, but kind of like that graph we looked at earlier on that PowerPoint, it could be that even though it doesn't exist, both of the sides would be approaching, say, positive infinity. And what I can do is explain this is what both sides are approaching. Infinity, because it's not a number, is not technically a limit, but what we're doing is we're describing what those values would be approaching, okay? So look at this. This asks us to find the value of as x approaches negative 4 from the left. Find the limit as x approaches negative 4 from the left. So here's what I would suggest that you do. First of all, can I plug in directly? No. And the reason I can't is because if I do, I get 0 in the denominator. X equals -4 is a vertical asymptote. Now, here's how I know it's a vertical asymptote. It gives me 0 in the denominator. Did it give me 0 in the numerator? No, I have a -4 in the numerator if I plug that in. So what that tells me is it doesn't exist, and there is going to be an asymptote there. Now, what I need to try to figure out is, would it be approaching a negative infinity or a positive infinity? And the way I'll do that is I'll pick a number that's on the side that I'm approaching from. So if I'm supposed to be approaching -4 from the left, give me a number that's pretty close to it, but is on the left side of -4. -5. So let's see what happens if we were to put -5 into this function. And what it's going to show me is whether I'm moving toward positive infinity or negative infinity. So if I put in a -5 for x, I get -5 over -5 plus 4. So that's a -5 on top over what's in the denominator? A -1. And a negative divided by a negative is a positive. Now, the number that I have here doesn't make any difference to me. But what I know is it's a +5. Does that give me an idea of whether I'm moving toward positive infinity or negative infinity? It should. Which way am I going? Exactly. So it is going to be approaching positive infinity. Now, I realize that's not technically, the limit technically does not exist, but what we're explaining is which direction this is moving. So we're just going to use that symbol to represent it. Now, what about -4 from the right? What could I do to test that out? Yeah, let's test using a number to the right of -4, but pretty close to it. So what's a good choice? -3. So that's going to be a -3 in the numerator over -3 plus 4 in the denominator. So I have a -3 on top over what's in the denominator, which is -3. So what do you think that means? It's going to be approaching negative infinity. So I've got this asymptote, and from one side it's going in a positive direction unbounded. The other side is going in a negative direction unbounded. So what would you tell me then about the limit of this function as x approaches -4? Is it going the same way? So I would have to put does not exist. If they were both moving toward, say, positive infinity, then I could say that the function is moving toward positive infinity as x approaches -4. But since they're going different directions, I can't say that. Now, here's another function. F of x equals 4x plus 1 over x minus 5 in parentheses squared. And we're supposed to find the limit as x approaches 5 from which side? From the left. Now, can I sub in directly? No, because if I were to put in 5, I would get 0 in the denominator. That means I've got a vertical asymptote when x equals 5. And I know that because if I plug in 5, I don't get 0 in the numerator, just in the denominator. So that's why it's a vertical asymptote. It's not indeterminate. So how would we figure out which way this thing is going to be going as x approaches 5 from the left? Well, hang on a second. It's not a -5, it's a +5. So if I'm to the left of +5, I want to use 4. So let's see what happens if we use 4 for x. So I'd have 4 times 4 plus 1 on top over 4 minus 5 parentheses squared on bottom. What is that giving me? And really, all I need are signs. What's going to be the sign in the numerator? A positive. What's going to be the sign in the denominator? It's also a positive. Even though 4 minus 5 is a negative 1, when you square something that's negative, you get back something that's positive. So the limit, yeah, because we want to be to the left side of 5. See, the negative sign is like a superscript to the right of 5. So it's not, look at the difference up here. We had a negative in front of the 4, and then you had either a plus or a minus up at the top. This one is a positive 5. So we want to be just to the left of positive 5. All right, so the limit as x approaches 5 from the left of this function has got to be moving toward positive infinity, right? Okay. Now, same function, but this time let's see what happens as we're moving toward 5 from the right side. Okay. And our function was, I'm going to recopy it since I don't have it on the screen, was 4x plus 1 over x minus 5 in parentheses squared. And what I'm interested in is the signs. If I plug in some number to the right of 5, maybe like 6, what are you getting back for signs? Got a positive on top over positive on bottom. So that means the limit of this function as x approaches 5 from the right is what? Positive infinity, right? And this, I don't know why the little arrow thing showed up there. We just want to answer the question, what is the limit as x approaches 5? Because it was the same from both directions. You're exactly right. Okay. So last thing we'll look at is determining infinite limits, making sure we see if we have vertical asymptotes, and then we're going to talk about horizontal asymptotes. And that actually is what we were looking at when we talked about those rules with rationals. So let me kind of sum this up for you here. I want you to make sure this makes sense. A vertical asymptote occurs only where a denominator would equal 0. Okay? Only where a denominator would equal 0. Now remember, if it's indeterminate, that would mean we also had 0 in the numerator. So if we had 0 in the numerator, we'd want to try to factor. Okay? If we had 0 over 0. But if we get 0 in the denominator and something different in the numerator, that's what tells us we have a vertical asymptote. Now, for horizontal asymptotes, a horizontal asymptote occurs when you look at the ratio of leading terms. Remember we said if you put it in descending order, you're only interested in the first term on the top and on the bottom because they're the ones with the biggest exponents. So we're only looking at the ratio of the leading terms in that rational function. Okay? If the power of the denominator is greater than the numerator, let me scoot this over a little bit. Okay, the power in the denominator is greater than the power in the numerator. Do you remember what that means? what did we say the limit would be? Is either x approaches positive infinity or negative infinity. If the denominator is growing faster than the numerator, then the horizontal asymptote is y equals 0. Remember we said the limit would be 0? And the limit is telling us what the y values are approaching. Now, if the powers are the same, then what do you have? The horizontal asymptote, sorry, this is messy, is the ratio of the coefficients, because that's what we said the limit would be. So that's what the y value is approaching, the ratio of those coefficients. And remember, if the numerator is growing faster than the denominator, there is no horizontal asymptote. It's just moving toward unboundedness, either positive infinity or negative infinity. All right, we good? So this is what we're going to look for. We need to see if we have a limit that is approaching either positive infinity or negative infinity. We need to see if we have a vertical asymptote and if we have a horizontal asymptote. So on these, let's first see if we can identify what would be the behavior that would occur. Well, first of all, let's see if we've got any points of discontinuity. All right, a point of discontinuity means we're going to have some value for x where it's not in the domain. Okay, instead of the whole set of real numbers, there's some value of x you can't use. Where would be the place that I could find that if it exists? What would give me trouble as far as domain values if what became 0? Which part of my fraction, numerator or denominator? Denominator. If the denominator becomes 0, that's going to be some value that's not in my domain. It's a point of discontinuity. So all I have to do is set the denominator equal to 0 and solve. So where is my point of discontinuity? Subtract 4 from each side. When x is negative 2, that's when I have a problem. Now, what does that tell me when x is negative 2? If I go back and look, would that be indeterminate, or does that mean it's a vertical asymptote? If it's indeterminate, the numerator would also be 0 when I plug in negative 2 for x. Do I get 0? Answer is no. I get a different number on top, 0 on the bottom. That means that x equals negative 2 is my vertical asymptote. So far, does that make sense? That's my test. If I can find some value that would make a denominator 0, that's where my potential vertical asymptote is. As long as that value doesn't also make the numerator 0, then it will be a vertical asymptote. Now, what I need to figure out is what's going to happen with end behavior. So I need to see what would be the limit as x approaches negative 2 from the left of this function. And then I'll see what would be the limit as x approaches negative 2 from the right. Okay? So let's look at this function. Pick something to the left of negative 2. All right, so if I used something like a negative 3, if I put negative 3 in the numerator, then I get 3 times negative 3, which is negative 9 plus 2. Is that a positive number or a negative number? Negative. Over. Let's put negative 3 in the denominator. So if I put in negative 3, 2 times negative 3 is negative 6. What's negative 6 plus 4? And a negative 6 plus 4 is a negative 2. And if I have a negative divided by a negative, that's a positive. So that means this is approaching positive infinity as x approaches negative 2 from the left. Agreed? Okay, now you guys test out, tell me what you get if you try a number to the right of negative 2. Okay, so coming from the right of negative 2, did you pick something like negative 1? All right, and if you plugged in negative 1 to this function, what sign did you get on top? You got a negative on top, but what'd you get in the denominator? A positive. And a negative divided by a positive is a negative infinity, right? So what we have, if we were trying to find the limit as x approaches negative 2, it doesn't exist. But I can tell what the direction is on either side of negative 2. It has one-sided limits that exist. Does that make sense? And as far as horizontal asymptotes, do I have any horizontal asymptotes? Remember how to test for those? Look back up here. Horizontal asymptotes occur when you look at the ratio of leading terms. Pay attention to the power of the denominator and the numerator. Well, look at our first terms here. Is one exponent bigger than the other, or are they the same? They're the same. They're both raised to the first power. What does that mean my horizontal asymptote is? You're exactly right. And my horizontal asymptote, excuse me, which is always a y-equal line, would be y equals 3 over 2. So I had a vertical asymptote, a horizontal asymptote, and I recognized that at that value that we had discontinuity, those were going unbounded opposite directions. Okay? Now, what about this next one? Do I have a point of discontinuity? I do. When x equals 5. Is it a vertical asymptote? No, because if I plug in 5, I get a 0 on top over 0 on bottom. What that tells me is it's a hole. It's not a vertical asymptote. And if I factor, I can actually come up with a value for if I wanted to find the limit. So I just have a point of discontinuity here, and I would see if I look, because it's a hole, there's not a vertical asymptote. Do I have any horizontal asymptotes? What was my test for that? Look at the exponents on the first terms. Which one's bigger? And if the top is bigger, what does that tell me? It's going to go, do I have a horizontal asymptote or do I not? It's unbounded. Remember, if the top's growing faster than the bottom, there's no horizontal asymptote. It's going to be unbounded. This is all that we have on this one. Okay? Now, this is just asking us to evaluate the limit. And we would use positive infinity or negative infinity where appropriate. So if I'm looking for the limit, this is where basically I'm checking for those asymptotes. Okay? I'm going to pay attention to these first terms, and I'm going to have to see where, look at those exponents. Which one's bigger, or are they the same? And what do you notice on this one? They're the same. And if they're the same, what would that mean my limit is? It's got to be the ratio of their coefficients. What is the coefficient that goes with x squared on top? 1 over 3 on bottom. And that means I have a horizontal asymptote at y equals 1/3. Okay? And all I have to do is look at the ratio of those first terms. How about on B? What do you think is going to happen there? Which one has a bigger exponent, top or bottom? Mm-hmm. And if it's growing faster on top than it is on bottom, what do I know? It's going unbounded. Now, do you think this is going to go toward positive infinity or negative infinity? All I have to do is look at these first terms. If I'm moving toward positive infinity to begin with, these x values are already positive. So they're just going to get more positive. And then look at my coefficients. They're both positive. So what do you think this is moving toward? Positive infinity or negative? Positive. Okay. Now, on these last ones, we just have to find the horizontal and the vertical asymptotes. So if I have a horizontal asymptote, that occurs by looking at the ratio of those leading terms. Okay? And my options are, I either have a horizontal asymptote at y equals 0, if the bottom's growing faster than the top. I have a horizontal asymptote at the ratio of the coefficients if the exponents are the same, or I have no horizontal asymptote because the thing is unbounded. The top's growing faster than the bottom. What do you think we have as far as a horizontal asymptote on A? And it's y equals 3 over 2. Horizontal asymptotes are y equals equations. Okay? Do I have a vertical asymptote? What do you think? Where would it have to occur? Well, it'd have to occur when what's equal to 0? The denominator. So set 2x plus 1 equal to 0 and solve it. And that'll give you x equals what? Negative 1/2. How are we doing? All right, so looking for vertical asymptotes, your denominator would be equal to 0. You just make sure that it doesn't also cause the numerator to be 0. If it does, it's not an asymptote, it's a hole. And your horizontal asymptote is going to be the ratio of those leading terms. Now, look at B. Do we have a horizontal asymptote here? Horizontal asymptotes come from looking at the ratio of these leading terms. What do you think? What is this thing going to approach? Which one's growing faster? And if the bottom's growing faster, do we have a horizontal asymptote? It's a population of China question. If I get more people I have to share my stuff with, and it's growing faster than what my stuff is growing, how much is everybody going to get? Eventually it'll be almost 0. You have a horizontal asymptote at y equals 0 because the bottom's growing faster than the top. Do I have a vertical asymptote? This one occurs here. You would set 3x cubed minus 3 equal to 0. And if I factor out a 3, I get x cubed minus 1 equals 0. The 3 doesn't impact anything, but if I set x cubed minus 1 equal to 0, what number could you cube and get positive 1? What would be the cubed root of 1? 1. I have a vertical asymptote at x equals 1. If I put in 1 for x, that would give me 0 in the denominator, but it doesn't give me 0 in the numerator. Okay, that one was a little unusual as far as solving for that vertical asymptote, but you guys can do it. I have confidence in you. And if we look at this last one, what do you think? Do we have a horizontal asymptote anywhere? Where is it? It's the ratio of the coefficients because my exponents are the same. So it occurs at y equals 3/2. Now, what do you think about any vertical asymptotes? If I have them, how do I find them? Yeah, I got to set the denominator equal to 0 and factor. So if I took 2x squared, let's see if I can get this right, 2x squared plus x minus 3 equals 0. All right, is it possible to factor 2x squared plus x minus 3? It is. I'm going to assume you guys can get the factoring done on your own. I do know 2x times x is going to be the only way. I'm going to get 2x squared. So I'll show you, if you were kind of doing the guess and check or backward FOIL method, how you could find this. In order to multiply last times last to get -3, I've only got two options. I've either got to have a positive 1 and a -3, or I've got to have a -3, or a positive 3 and a -1. But I have two places, besides having two signs, that I have to pay attention to. I've also got two places where the 3 and the 1 could be written. Remember, I'm going to want to use FOIL and end up with a positive x for that middle term. That tells me I want a 3 here and a 1 here, okay? And since I'm multiplying and get a negative, I know one of these has a plus, one has a minus. Since I want it to add up to be a positive x, I should have 2x plus 3 times x minus 1. And so if I were to solve this, I have two vertical asymptotes. I would set 2x plus 3 equal to 0, and I would set x minus 1 equal to 0. So subtract 3 from each side here. And if 2x equals -3, where is one of my vertical asymptotes? -3/2, you're right. If I said x minus 1 equal to 0 and solve, where is my other vertical asymptote? X equals 1. And